Let's finish up our unit on three-dimensional objects as we take a look at properties of similar solids. It'll be similar to what we talked about with similarity. We'll find connections and see how things are proportional. Just like they were with similar two-dimensional figures, that proportionality will play out with three-dimensional figures as well. So I'd like you to first start off by doing this activity as you compare volumes and surface area of these 5 cylinders. We want to see if there's any kind of pattern as we compare the similarity. So you're going to calculate the surface area and the volume of those figures. And remember, here's the formulas for those in case you've forgotten them. So pause the video, restart it when you're ready to check your table out. So we see that the surface area, when we increase the height by 1 unit and the radius stays the same, that the surface area increases accordingly by 2 pi every time. And the volume increases by 1 pi every time. So let's look this time when the radius and the height both change. How does that affect our surface area and volume? So once again, if you haven't done this yet, calculate the volume and the surface area for each cylinder. And I've relisted the formula once again if you need it. 2 pi r squared plus 2 pi r h. So once again, pause the video and restart it when you're ready. And as we take a look at the surface areas and volumes, you can see that surface area is 4 pi, 16 pi, 36 pi, 64 pi, and 100 pi. And the volumes are pi, 8 pi, 27 pi, 64 pi, and 125 pi. So we see that these now, the first time, just the height was increasing. They increased by a common difference. Now we kind of see them increasing more and more each time. So why is that? Since we increase the radius and the height, we see that when both the radius and height increase, we're multiplying more than just one dimension. So we're moving in 3 dimensions instead of just 1, increasing in size. So when the dimensions of a solid increase by a factor of k, how does the surface area increase? So this was times 2, and here we're going times 3, both dimensions, times 4, and times 5. So how are the surface areas increasing? When we doubled, it was 4 times bigger. When we tripled, 9 times bigger. 4 times is 16 times bigger. 5 times is 25 times bigger. So you can see that those are all the squares. So we're increasing by k squared with the surface area. How did the volume increase when we increased by a factor of k? Well, 2 times bigger was 8 times. 3 times bigger was 27. 4 times bigger was 64. 5 times bigger is 125. You see, 2 to the third is 8. 3 to the third is 27. 4 to the third is 64. And 5 to the third is 125. So it's increasing by a factor of k to the third power. So because every dimension is increasing, so not just the length or the height as it was originally. When the height doubled, this doubled. When it tripled, volume tripled. Same with the surface area. When the surface area got 5 times, the height increased 5 times. Here we're increasing not proportionally in that same way. We get 8 more, which is tripled. So when we're increasing every dimension, 3 dimensions, we get the scale factor 3 times. When the surface area increases, when the scale factor is k, we're increasing all the dimensions twice because we're measuring surface area in 2 dimensions, but volume is measured in 3 dimensions. So if the factor is 5, how many times greater is the surface area? 25, because surface area is measured in square units. So it will be squared. Volume is measured in cubic units. So if all the dimensions are increased by a factor of 5, 5 to the third power is 125. So keep that in mind as we start working through similar solids today. So solids that have the same proportional linear measures are similar solids. So which cylinder is similar to cylinder A? B or C? Pause the video, do any calculations, and restart it when you're ready to check. Okay, so let's take a look at what you got. So if we compare cylinder A, its dimensions, its height is 4. Cylinder B's height is 3, so 4 to 3 ratio, and the radius 6 to 5. 4 to 3 and 6 to 5 is not the same ratio, so they're not proportional. Compare A to C, height 4 to 5, radius 6 to 7.5, those both reduce to 4/5, so they're proportional. So A would be proportional to cylinder C, because both their linear measures are proportional. Now let's find the missing measure in these similar solids. So if cone X has a radius of 5, slant height 13, cone Y has a radius 7, slant height of L, let's find its slant height. So it's just like comparing corresponding parts in triangles, except now we've got a three-dimensional figure. So what can we match up? We can match up radius from cone X to radius from cone Y. And X is 5, Y is 7. Excuse me. Sorry. And then we compare corresponding slant heights. And those should be proportional. So the slant height from X and the slant height from Y. Okay, so we match those up. Slant height from X is 13, Y is L. Let's figure that out. So 5L equals 13 times 7, 70, 91, divided by 5. And I believe that's, let me check my calculations. So as we divide 91 by 5, we get 18.2. So slant height for cone Y would be 18.2, and we're measuring in yards. Okay, so just match up corresponding sides. If they are similar, they would be proportional. Let's find the surface area. These pyramids are similar. Let's find the surface area of pyramid A. Well, I know the surface area of pyramid B is 600. So what will the surface area of pyramid A be? I'm going to pause the video and let's see if you can figure it out on your own. Restart it when you're ready to check your answer. All right, so you recall that the surface area of a figure, we're measuring in 2 dimensions. So if we compare the surface area, we need to square its the ratio of the side lengths. So as we're comparing the side lengths, we know the surface area of A we don't know. Surface area of B is 600. We don't know the corresponding proportion, but we do know the height of A is 6, the height of B is 10. So 6 to 10, and if I square those, that will give me my true proportion. So it's really 36 to 100. And so if I solve for S, multiply both sides by 600, I get S equals 216. So the surface area of the pyramid is 216 square feet, because the true ratio is 36 to 100, because I'm finding surface area, which is 2-dimensional. So keep that in mind as we're looking at 3-dimensional. If we're comparing volumes, it's going to be the side length cubed, K cubed. Remember, as we talked about our investigation at the beginning. So if all dimensions are multiplied by the same scale factor, we know the volume of A to the volume of B is equal to a comparison of the different side lengths A to B cubed. So why don't you find the dimensions of the new tank at the aquarium? If all the dimensions are doubled, what will the volume of the new tank be if the original is 2,000 cubic feet? Restart the video when you're ready to see an explanation. Okay, so if we take a look at the original volume, it's 2,000 if we're doubling all the dimensions. So it's a 1 to 2 ratio. So the original dimensions are 1 to 2, so if we cube that, it's really going to be 8 times bigger, because 1 cubed is 1, 2 cubed is 8, so it's really 1 to 8 ratio. So times 8, this will be 16,000 cubic feet. So the correct answer would have to be D. So hopefully that makes sense when you think of similar solid figures. Think of it in terms of what we've learned about with similarity. Everything is proportional. But if we're finding area, it's proportional in 2 ways. So we need to square that scale factor. And if it's volume, we're thinking of 3 dimensions. So we need to cube our ratio. So you'll have some practice problems that you work on in class. If you have any other questions, please ask.